Good morning, everyone. So this is group number one with our topic heat exchangers. What are heat exchangers? So heat exchangers are devices which are designed to transfer heat from one fluid to another. Uh, and there are multiple types of heat exchangers which are as follows. Shell and tube heat exchanger, which consists of series of tubes with different fluids at different temperatures flowing through them, and they transfer heat amongst themselves. There are plate heat exchangers, which consists of multiple thin plates which are stacked together, allowing heat exchange between fluids. And then there are air-cooled heat exchangers, which uses air as the cooling fluid, and it is often found in systems where water isn't available, like your computers. And then lastly, there are fin tube heat exchangers, which focuses on increasing the surface area, uh, which maximizes the heat transfer, and it is used in air conditioning and refrigeration. Principles of working of heat exchangers. So heat exchangers works basically on the first and the second law of thermodynamics, which states that in a heat exchanger, the heat lost by the hot fluid must be equal to the heat gained by the cold fluid, assuming no heat loss to the surroundings. And the second law, which says that there would be entropy generated in this heat transfer process because we cannot ignore the irreversibilities. So how do heat exchangers work? The process of heat exchanger is basically transferring of heat between two fluids without actually mixing them. And so the first main process is the heat transfer process, which takes place in a designated section, transferring heat to the cooler fluid without direct contact. One of the processes involved is the conduction processes. So, like if two pipes are in contact with each other, so heat transfer from the hotter fluid to the cooler fluid takes place through the conduction in the material. Moving on, we have the convection processes, which are individual processes taking place inside the fluid itself due to difference in temperatures. And also, we have the phase change processes in some heat exchangers, in which one of the fluid is undergoing a phase change. The heat exchangers find a wide variety of applications in our daily life and industry as well. So, heat exchangers are used to improve efficiency, prevent overheating, improve safety, and use heat energy most efficiently. They are used in power plants, production plants, reaction chambers, air conditioner, boiler, and anywhere where a smooth energy transfer is required. So as you can see, refrigeration, oil and gas production, paper and pulp industries, oil and refinery petrochemicals, everywhere. So heat exchangers are used everywhere. We look at some of the uses of the heat exchangers, which include geysers. So geysers, we use geysers in our daily life, and as the winter sets in Kanpur, we have also started using geyser in our halls. So these are water heater devices which are used in domestic use and commercial use as well. There are two types of geysers, which include storage geysers and instant geysers. So the difference between them is basically having and or not having a storage unit. So these are the key components, which consist of a heating element which is responsible for the heat transfer process, and the water tank, which is responsible for storing, thermostat control, which is responsible for cutting off the power supply when the water reaches a certain temperature, and the hot water outlet, obviously. So these are the key processes in the heating cycle, which include the water tank, which stores the cold fluid and keeps the hot fluid when it is heated by the heating mechanism, which consists of the electric water heaters and the gas water heaters, which is in turn controlled by the thermostat, which cuts off the power supply when the water reaches a certain level. So another use of uh, heat exchangers are the refrigerators. So refrigerators are used in daily life for storing foods, keeping beverages cold and preserving leftovers, as we see in our fridge, which we have in our homes. And for industrial uses, they are used for preservation of perishable goods, pharmaceuticals, chemicals, and beverages, as well as in processes like fermentation and processing and food processing. So this is another very important use of heat exchangers. So it is a type of a cooling system which work on this cycle of evaporator, compressor, condenser, and expansion valve. So the evaporator is responsible for sucking in heat from the low temperature region in the form of QL, which and the refrigerant which passes through the compressor, which increases the pressure and temperature, and in turn the refrigerant loses out heat in the condenser, which is lost to the surroundings, which and the refrigerant then passes to the expansion valve, which results in a drop in pressure, and in turn it goes to the evaporator, and this is how the cooling cycle works. Application of cooling systems, I have already covered that they are used in our daily homes for for refrigeration. They are used in automobile overheating. They are also used in our electronics to prevent overheating. In industry, they are used for power plants, data centers, and manufacturing. Nowadays, data centers are also being put inside the oceans to uh, maintain the temperatures over there. So this is the IITK refrigeration facility. I actually visited that thanks to my ESO 201 tutor, and this reduces 3,200 ton of cooling, and this is the actual cooling cycle which runs, and this green pipe and the blue pipe. The green pipe brings in the refrigerant, and the blue pipe takes it out. So yeah, so well, thank you. This was our presentation.